Alrighty guys, we'll get started. So welcome to the Advanced Maths Crash Course. We'll dive straight in because we do have a lot to get through. So just a bit of housekeeping. We will need to be speedrunning this whole crash course, this whole session. There's a lot to get through. So pretty much the way that we'll be structuring it is that you'll have 30 seconds to just think about how you would approach the question. So I'll pause and give you guys some time to think to see if you know the steps that you would take to solve the question, and then we'll walk through the question. Now, some of the questions will be skipped just because there's not enough time to go through everything, but we'll still make a mention of them. But they will appear in the annotated version of the slides that you receive when we email out the resources. Now, if you do have any questions for anything that you come across or any of the questions that we go through, leave them to the mid-session break or to the end of session break. That's when we'll be able to answer your questions, just because we are on such a time crunch. And if you do think of anything after that, you can just email us and we'll answer the questions through email. So let me just check the chat. Okay. If you have any technical issues, just exit the meeting and rejoin. So sometimes you can't hear. So let me just reply to this person. Okay, so usually happens to the first few people who join. Yeah, so just keep your mics muted. You don't need to turn on your video either. And like I said, if you do have any technical issues, you can just rejoin to the Zoom link that you were sent through the Eventbrite email. If there are like some serious problems and you really want to join, you can give us a call on this number and hopefully we can sort something out for you guys. But the meeting will be recorded. So if you do encounter issues, just try to rejoin at the end because that's when we'll have a QR code that you need to scan. And send me your email, to which will then send out the resources. So you do need to stay until the end. If you do have issues, just rejoin and come back at the end. Okay, so let's quickly talk through some exam tips and tricks. So there are pretty much just 2 weeks left until your prelim exam. So that's 14 days. And if you're doing 7 subjects, that's basically 2 days of study per subject. So I'm not putting this in to freak you guys out. It's just if you haven't started to study yet, hopefully this will give you a little push and put things into perspective. So imagine if your advanced maths exam was in 2 days' time, how would you be studying? That's pretty much the level of study that you need to have between now and when your prelims actually start. Another thing is that notes for your content-based subjects should be pretty much finished by this stage. So content-based subjects are subjects like, biochem, like business, physics, and you should be moving on to really understand the content or doing practice questions. Now for maths, you should be doing 3 past papers per week at this stage under exam conditions. So I say at least 3. Maybe that's a bit much, but if you are doing just advanced maths, then you should be doing 3. If you're doing extension 1 maths, so you should be maybe doing 2 for extension and then 2 for advanced. Now, you should be doing these under exam conditions. So sit down and take 2 hours. That's usually how long the prelim exams are. And try to see if you can solve the whole paper within those 2 hours. And then afterwards, you should mark your paper and see how you went. Now, you should then subtract 10 to 15% from whatever mark that you got to see how you would perform in an actual exam. So obviously, when you do it at home, it's much more relaxed. You don't have that exam pressure or exam stress. So you'll perform a bit better if you're doing it at home. So say that you're aiming for 80% in the actual exam, and you should be scoring maybe 90 to 95%. Or if you're aiming for, say, 60% in your actual school exam, you should be aiming for 70 to 75% in your practice. So this part is really important. And this is the part that will really allow you to improve for advanced or for any math subject. Now, in order to achieve this level of study, you need to create a strict study schedule. So it's not easy to do 3 past papers per week, past papers 3 hours. Sorry, I'll just get whoever that is. Mute. So just make sure your mic's on mute.
You're going to return it?
Okay. Yeah, so create a strict study schedule in order to fit in all that study that you need. I would recommend at this stage that you should be studying 4 hours per day after you come back from school, because we're kind of in the crunch zone. You don't have to be studying like 4 hours every day for the rest of your HSC, but in this crunch time, you do need to be able to put those hours of study in and do a little bit more on the weekend. So maybe try for 5 to 6 hours on the weekend. But really, this is all about consistency. If you study 10 hours one day and don't do anything for the rest of the week, then you haven't really put in enough study for that entire week, even though you did 10 hours in one day. You know, that's maybe just 2 hours of study per day. If you decide to study one day, 10 hours, and the rest of the week, just didn't do any study. So consistency is really key, especially in the lead up to exams. And the very last thing I mentioned is that if you don't already know, Desmos is a great graphing calculator. So a lot of things in TrueUnit that students struggle with are graphing related things. So for example, domain and range, or how to graph certain functions, also trig functions. If your school is going to assess trig functions, then this is a really good tool to use to see how all these functions look, especially when those functions are being shifted around. If you play with the Desmos, you can shift around functions and see how they're changing. So just by using Desmos, you could learn how to graph from scratch pretty much without any outside help. And the very last thing is THSC. So this is a website that has past papers. If your school hasn't provided you with any past papers, or you don't know anything about what past papers are, or if you don't know where to access them, there's a bunch of websites, but this one's a really good one to go to THSC, bunch of papers. Now, the math syllabus has changed. So in, I think it was 2019, I'm not too sure. It could be either 2019 or 2018, the new syllabus came into play, one of those 2 years. But if you do 2019 and 2020 papers, that will give you a really good idea of what will come in your own exams. But obviously, each school at this stage may have done different topics, so just be wary of that. If there's some stuff in the paper that you haven't seen before, just take it out and create a new time limit on a pro rata basis. Okay, so next thing, this is the order of topics. So there's 7, these are pretty much the main topics in the Advanced Maths Year 11 course. I will be taking you guys for the first 4, and then Swazian will take you for the last 3. Okay, so just one other thing before I get into it. I'm pretty sick today, so if I have to clear my throat or blow my nose, I apologize in advance. Okay, so let's get into it. So we'll start off by looking at types of functions and relations. So this would have been one of the very first things that you did in advanced. Now, a function, if you remember, is anything that passes the vertical line test. So if you run a vertical line through your graph and it only cuts the graph at one point, it means it's a function. So that means it passes the vertical line test. Anything that doesn't is a relation. So all the examples that we have on the screen here pass the vertical line test. And the thing is, it needs to pass the vertical line test at all points, not just at specific points. So if there's any points on the graph where it doesn't pass the vertical line test, then it's not a function. And we'll see an example of that in a bit. Okay, but this is where the tricky part sort of comes into play, the different types of functions and relations. So you've got one-to-one functions. Now, this is pretty much a straight line. So if you don't know what one-to-one is, or it's a bit confusing, pretty much this format, this first thing in the format tells you how the x's are related to the y. So in this case, every x value maps to just one y value. So for example, if you had it in function or in this set notation, maybe you would have seen this at school. It just means that every x value maps to one y value. And this might be a little bit more obvious when we actually look at the questions. So if you're a bit confused, don't worry too much. Okay, so with a one-to-one function, it will pass the vertical and horizontal line test. So this is maybe something you wouldn't have learned at school, but it's a really useful way to differentiate between the different types of functions and relations. So the horizontal line test is pretty much the same as a vertical line test over the horizontal line instead of a vertical line. Okay, next we have a many-to-one function. So here the many refers again to the x and the 1 to the y. What this means is that multiple x values, okay, map to the same y value. So for example, 1 might be mapping to a y value 1, but then 2 also maps to y value 1. And if you're still confused about this idea of mapping, just keep in your head and we'll clarify it through some examples. So with many-to-one functions, they are functions, so they will pass the vertical line test, but they won't pass the horizontal line test. So that's an easy way that you can differentiate between one-to-one and many-to-one functions. A many-to-one will not pass the horizontal line test. Okay, so let me just check the chat. Okay, so apparently the screen is a bit blurry. So if you guys have that same problem, let me know. It could be, I'm not sure if it's my internet connection or what. Okay, we'll see how we go. If it's still a problem, just let me know. Okay, next we've got one-to-many relation. So in this type of relation, so we're no longer looking at functions. We've got one x value. So let me just draw this up first. So we've got one x value that maps to multiple y values. So many just means more than one pretty much. So one x value is mapping to say 1, but also 2. And say 2 also maps to 2 and 3 and 4. So one x value is mapping to multiple y values. So that's a one-to-many relation. And again, this will be clear when we look at an example. But for such a relation, okay, you won't pass the vertical line test because it's not a function, but it will pass the horizontal line test. So if you have something that's not a function, but it's passing the horizontal line test, then it's a one-to-many relation. Okay. So just 1 second. And lastly, we have many-to-many relations. So here we have a relation that doesn't pass the vertical line test or the horizontal line test. Okay, let's have a look at some examples. So this is a little bit more clear. Oh, it's a little bit blurry. Okay, so apparently it's blurry when I move to slide, but it's okay once it's settled. So hopefully, so let me check my internet connection. Okay, hopefully it fixes itself fast. But the recording should be clear. So if there's anything that you missed, hopefully you can see in the recording. Sorry. Okay, let's have a look at this first one. So have a think about which option you think this might be. But if you have a look, this will pass the vertical line test. So everywhere in the graph, you'll only cut once, which means it's a function. So it's one of the first two. And let's now apply the horizontal line test to differentiate between the first two. You can see that it actually cuts the function of the graph in 2 places. So that means it's a many-to-one function. So this is an easy way that you can use, easy way that you can differentiate between the two. So just to summarize, the vertical line test system passes, but the horizontal line test, it fails. Okay, let's have a look at this one. So have a think about which option this one might be. Okay, so let's have a look. So the vertical line test, it fails. So this is not a function, which means it's one of the last two. Now let's have a look at the horizontal line test. So if we draw a horizontal line anywhere in this graph, you'll only cut once. So the horizontal line test, this one actually passes, which means it's a one-to-many relation. Now, if we draw a vertical line here, let's say that this is a value of 2, x is 2, and let's say this is 0.5, and this is, let's say, -3. So what we have here is one x value mapping to multiple y values, okay? And this is why this is a one-to-many. So one x value maps to multiple y values. So it's a one-to-many relation. Okay, let's move to the next one. So I'll give you guys just a second to think about this one as well. Okay, so if we have a look at this graph, it passes the vertical line test, okay? But it will fail the horizontal line test, okay? So because it passes the vertical line test, it means it's a function. So it's one of the first two. And because it fails the horizontal line test, it must mean that it's a many-to-one function. Okay, let's have a look at the next one. So have a think about this one as well. Give you guys just 10 seconds. Okay, so for this one, it fails a vertical line test. So it means it's one of the last two. Let's have a look at the horizontal line test. It fails that as well. So this must mean that it's a many-to-many relation. Okay. Let's have a look at this one. I'll give you guys just a second to think about which one it might be. Okay, so let's have a look at the vertical line test. Here you'll obviously pass. In this section, you'll also pass. But this is really at this discontinuity is where we need to focus our attention. So if we draw a line here, it actually passes the vertical line test because this particular point here is kind of shared between this segment here and this segment here. Yeah. But the thing is, this one is colored in. So this particular point is actually just belonging to this segment and not to this segment. So there's no overlap. Meaning here, it will actually pass the vertical line test. Okay, so it'll only cut the graph once because this part is an open circle. All right, now the horizontal line test, well, the function doesn't exist anywhere here or here or here. So it's really just these lines, which are horizontal lines. And because it will cut, if we draw a horizontal line here or here, it will cut the graph an infinite number of times. It actually fails the horizontal line test. So this first part tells us it's a function, but the second part tells us that it's a many-to-one function, okay? Now, if this part was actually colored in, okay, let's say that both parts were closed circles, okay, it would no longer be a function, it would be a relation because it would fail the vertical line test. It would cut the vertical line here and here, so twice, and that would mean it would be a many-to-many relation, okay, just as a little extra point. And that extra point may help you to answer this question. So have a think about this one. I'll give you guys just a few moments to think about which of the four this would be. Is everyone still finding it to be really laggy? So I've just got a message from Rafid saying it's very laggy and buffered. Can you guys hear me okay? Is it just the screen that's really laggy? Okay, apparently the screen is cooked. Okay, what about the video, like my voice? Can you hear me in real time, or is that really laggy too? Okay, just the screen. I wonder what we can do. Okay, well, I'm checking it for the first half, so maybe once we switch over to SWOT, then it's okay. I feel like it's my laptop. That's really annoying. All right, so for this one, let's just quickly go through this because we are kind of short on time. So it will fail the vertical line test. So it will pass it in these sections. It will pass it in these sections as well, but it will fail in this section here. Okay, so in this section here, it will actually fail. So it's not a function. So we'll have to look at the second two. Now, from the previous question, we saw that a graph like this fails the horizontal line test. So this means that it's a many-to-many relation. Okay, I'll pause here in case it needs a second to clear itself up. My Wi-Fi looks to be okay. I suspect maybe something to do with my computer. Okay, let's have a look at domain and range. Maybe I'll just like pause a bit so that it can like clear itself up on your end. Okay, so with the domain and range, to really understand domain range, if this is something that you're confused about, which is the case for a lot of students, think about functions in this way. So functions are just a series of inputs being put into a machine. Okay, usually that machine contains whatever equation that the function is. So for example, if you had a function that was f of x is equal to x squared, what this machine does is it takes any input or numbers from x, and then it will square that number in this function machine compartment, and then it will output that number. So for example, if we're plugging in 2, okay, 2 will sort of go into this function machine, it will get squared, so 4, and so the function machine will produce an output of 4. Now, understanding this mechanic was also really important for understanding how translations work. And we actually have a video that explains how this function machine works and how it ties into translations. So if you want to understand more about that, I'll link it with the resources that we send out. But for the time being, we'll focus our attention on the inputs and output section. So the inputs are basically, sometimes the inputs can be limited. So that's what the domain is. The domain is what we can actually plug into this function machine. For example, if we have a function that takes a square root of numbers, then we can't put in anything that's negative. The function machine won't accept anything that's negative. And a lot of the time as well, the function can only output certain values. So for example, with x squared, it can only output positive numbers in this particular function machine. Okay, let me check the chat. I've got some questions. Okay, can you guys hear me? I don't know why we're having so many technical issues today. My mic isn't muted. Can you guys hear me? Okay, maybe, okay, so if your sound cuts out, just rejoin the meeting. For some reason, I don't know, we had this issue with extension 1 yesterday as well. Just rejoin the meeting. Hopefully that fixes. So let me just message that person. Okay, so yeah, if you guys have joined through the web, like website version of Zoom, you might experience a lot more issues than if you have the Zoom app. So try to actually join the meeting through the Zoom app, and that way it should run a bit smoother on your end. Okay, let me just keep continuing. All right, so pretty much this slide explains that domain is pretty much a set of input values that we can have. And in terms of this graph, it's kind of where the graph exists bound between vertical lines. Or think of that as kind of like goalposts. That's where your graph is sort of confined in between. Sometimes a graph will extend forever, in which cases the domain is all real values. And in some cases, you'll be restricted. Like in this case, the graph only exists between these two goalposts. The range is also a similar idea, but for horizontal goalposts. So in this case, the graph exists between 0 and 3 inclusive. Okay, now to properly understand domain and range, you need to actually have an idea of what the graphs look like. If you have no idea what the graphs look like, it makes it really hard to understand the domain and range. So let's start off with the basics. So for a line, this is the two general forms of a line that you might see. For a line, the domain is all real values and the range is all real values. So we can't confine this line to within vertical or horizontal line goalposts. It just extends forever in the left and right and also up and down. Okay, next up is the third graph. So with this graph, it does have some limitations. Now, what we've actually put in the slides here is a not the most basic form, but a surrogate graph that's had some translation done to it. So this graph has been shifted A units to the left and shifted up B units. So now it starts at negative AB and it retains that shape of a surrogate graph. For this particular general format of a graph, the domain will be x is greater than or equal to negative A because we need the inside to be something positive or equal to 0, and the range will be greater than B. So if you just had a standard square root graph or surrogate graph, the domain here is all real values, and the range, sorry, not all real values, the domain is x is greater than or equal to 0, and the range is also y is greater than or equal to 0. And if we shift it to the left by A units, then this will also be shifted to the left by A units. Or if it's to the right, this will be shifted to the right. If the graph has been shifted down, this will also be shifted down or up according to your translations. Now you can also have an upside down version of this graph. So instead you could say have something like this. And that's if we had a negative on the front of this graph, and this was negative as well, for example, in this case. If it was the negative version of a graph, this would just be y is less than or equal to whatever point this is. So let's say that we had minus and minus here. So this point was minus A minus B. The domain for this would be x is greater than or equal to minus A, and the range would be y is less than or equal to minus B. Okay, you just need to be aware of the translations that will happen and manipulate the domain and range according to that. Okay, next up we have parabolas. So this is a very common question that comes up in exams for you to find the domain and range. So we've got it in a fairly general format. If you have a right way up parabola, so a concave up parabola as we have here, the domain will be all real values, and the range will be y is greater than or equal to the y coordinate of the vertex. So for these parabola domain questions, you need to be able to find the vertex, the y coordinate of the vertex. For a concave up, like I said, it would be y is greater than or equal to b. For a concave down, the range is still all real values. Sorry, the domain is still all real values, and the range will be y is less than or equal to b, okay, rather than greater than or equal to b. Okay, but for both cases, domain is all real values. All right, next up we have cubic graphs. So this is a very generalized format for a cubic equation. But what I've got is, I wanted to show you guys the different types of cubic graphs that can come up. And this is especially important for any really hard questions that you might get in an exam. There have been questions that I've seen that test this bit of knowledge. And it's not really something that's commonly taught. It's kind of something that's assumed. But for a cubic, you can have 3 scenarios for a cubic graph. Kind of like a quadratic, where you can have a positive definite, negative definite, or one root, or 2 distinct roots, which is something we'll talk about later in the discriminant section. But for cubics, we kind of have a similar principle. So Cubics can either have 1, 2, or 3 distinct roots. Okay, they can't have 0 distinct roots or 0 roots because of the nature of these graphs. But a 1 root cubic looks like this. A 2 distinct one looks like this. It's got a double root and 1 other root. And for a 3 distinct root cubic graph, it just looks like a standard one that you might have already seen. But for a cubic, because of the shape, you can't contain it between vertical or horizontal goalposts. They extend forever left and right and up and down. Domain and range are both oral values. Okay, next we've got a circle. So for a circle, let's say that we have it in very general form. For some reason, the 2 doesn't stay up here, but this is meant to be a squared. So let's say that this is what it looks like roughly. Okay, so it's got center HK and radius R. Now, the circle will extend to the right by R units. So this point here will be H plus R K, and this point here will be H minus R K, yeah? So starting from the middle, we go R units to the right and R units to the left. That's why the domain is given by this, yeah? And this looks very complicated, but if you had actual numbers, it would make a lot more sense. We're just going to the right by how many units of radiuses, and to the left by how many units of radiuses. For the range, it's a very similar idea. So we can go up by R units, and we can go down by R units as well, okay? So that's why the range looks like this, and there's a slight typo here. This is supposed to be minus R, okay? So hopefully that makes sense, but this one's fairly intuitive. Okay, next up, we've got semicircles. So this is not the most general form that you'll see. This one has just been shifted up by B units, and it's this one that this graph is representing. You could have shifts to the left and to the right, and you need to adjust the domain according to what we talked about earlier. So for a semicircle of this format, the domain will just be between negative A and A. So that's the restrictions imposed by square root. The inside can be 0 or a positive number. The range, okay, for a normal graph, for a normal semicircle graph is between 0 to B, okay? In this one, we've just shifted it up, sorry, 0 to A. This one, we've shifted it up by B units. So that's why we've got, instead of 0, we've got B, and instead of just A, we've got A plus B, okay? So this would be B here, and this would be A plus B. Okay, now for an upside down semicircle, let's consider this situation here. We'll just assume that this is the very basic format of a semicircle. The domain here would be between minus A and positive A, and the range would be between negative A and 0 this time. So instead of it being confined in the positive space, this time the greatest value would be 0, and you would go down to where the radius goes down to, or the y-intercept, which is negative 8 units. All right, next up we've got hyperbola. I think this is one of the very last ones. So for a hyperbola, this is what it would look like in a pretty general format. We've got a shift B units to the right and C units up for this particular hyperbola. The domain is all real values except B, because the denominator can't be 0. So that's the equation of the vertical asymptote. And then we've got the range. So the range can be any of the values, except this fraction can never be 0. Yeah, there's no values of x for which this fraction can be 0, but it can get really close to a value of c. Yeah, so this part can approach 0, but never be 0, which means that overall this part approaches c, but can never equal c. So for hyperbola, the range is all real values, but it can't be equal to the horizontal asymptote. Okay, so we've got just 2 more left, guys. Here's a logarithmic graph. So this is a fairly basic version. So the pure version of a log graph would just be this part here. The A, the base, it doesn't change the domain or range. So it kind of will just affect the shape a little bit. You can play around with that in Desmos, see how different values changes the shape. We've just shifted this up by b units. But because the range for a log graph is all real values, this shift doesn't change anything for the range. And for the domain for a log graph, the argument of a log always needs to be something positive. It can't equal to 0. It needs to be something greater than 0 or something positive, and it can't be negative either. So in this example, there's actually a vertical asymptote of x is equal to 0. Okay, and the last one, we've got exponential. So for extension 1 students, you guys should be able to tell me what the difference, or like how these are related. Well, you don't need to actually tell me, but you should be able to. The exponential graph is actually just the inverse function of the natural log graph. And that's why it shares a lot of the same properties. So 1 second. Okay, so for an exponential graph, this time we don't have any restrictions on the domain. Yeah, the domain is all real values. And that makes sense because if this is to be the inverse, it should take on the range of the log graph. So the domain is all real values. But the range has a limitation. So before in the log graph, the domain had a restriction, we should now mean that in the exponential, its inverse, the range should have a restriction. If you're just a student kid, you don't need to worry about that. But in this particular example, we've got the regular exponential graph shifted up by a units. So usually the range is y is greater than 0. So if it was just y is equal to e to the power of x, the range would be y is greater than 0. But since we've shifted it up by a units, the horizontal asymptote also gets shifted up by a units. Okay. Oh, we've got one last one, the absolute value graph. So this is a pretty generalized format of the absolute value graph. If we have some function in here, it could be anything. The domain for this particular absolute value function, because the absolute value functions themselves aren't really a function, they're more of a transformation. So the domain would depend on what you actually have inside the absolute values. And for the range, it would be whatever restrictions you have on the function inside. But usually it's just limited to positive values. So if you're shifting it up by a units, it would just be whatever you originally had plus a units. This will be a bit more obvious when we look at the examples. Okay, so here are 3 examples I want to talk through. So what I want you guys to do is just to have a think about these 3 questions. See if you can know, or see if you know what steps you should take to work it out. So you don't need to like mentally work it all out, but just see if you would have an idea of what steps you need to take to actually work these out. Give you guys just a second to think about that. Okay, so part A, this is a parabola. So the domain would be all real values, okay? But the range, if you remember from our slides, should be greater than or equal to the y value of the vertex coordinate. So here, the x coordinate, so in order to work out the y coordinate of the vertex, we first need to work out the x coordinate. So the formula would be minus b, which is minus 3, so positive 3, divided by 2 times a, so 2 times 1 in this case. So the x value of the vertex coordinate is just 1.5. To figure out the y coordinate, you'll just need to take this value and sub it into the original equation. And this, if you do, will come out as negative 0.25. So the range would be, and you need to double check to see if this is a concave up or concave down. So in this case, it's a positive coefficient of x squared, so it's concave up. So we'll have greater than or equal to negative 0.25. Okay, now for part B, in this case, the function inside the absolute values is just a linear line, which doesn't have any restrictions. The range, so normally is all real values for a line, but since we're taking the absolute value, we can no longer have any negative values. And we don't have any shifts here, so the range will just be y is greater than or equal to 0. And if you imagine that this is just a regular absolute value graph shifted 1 unit to the left, which makes sense. Okay, and for part C, this is a semicircle. So the domain should be between -2 and +2. And the range, this is an upside down semicircle. So it will be between -2 and 0. So if you're a bit confused about that last one, the semicircle looks like this. Okay. Sorry, let me just pause here for 1 second in case it's still blurry. Can you guys let me know if it's still really laggy on your end? If it is, hopefully you won't have to endure too much more when sorting comes in. Hopefully it's not laggy. Okay, it's still laggy. Okay, on and off. I wonder if it's my internet on my computer. Okay, but anyway, let's move to this one. I want you guys to pause and think about how you would do this question. Picture if you can draw this out in your mind, or maybe you can draw a rough sketch in your book. I'll give you guys 30 seconds to think about this one. Okay, let's have a look at this one. So this is a piecewise function, and a lot of the time students get really confused about how to draw a piecewise function, but really it's just drawing two graphs on the same axis. So there's nothing that's actually too difficult about this. And this is pretty wonky, so let me just fix this up. Okay, so with a piecewise function, you've always got a boundary. So in this case, the boundary is at x is equal to 2. Okay, so let's just draw this in. We'll get rid of this dotted line afterwards, but it's just for us to think about the boundary. Now, on the left-hand side of the boundary, so for values less than 2, so on the left-hand side, we have this semicircle graph. So if we were to just draw in this semicircle graph, let me retry that. It will look like this, okay? And the thing is, in this case, the full graph will fit. A lot of the time, the graph won't be able to fit on the left-hand side. Sometimes, if you have like a line, for example, it will make its way across to the other side. In those situations, you need to take only what's on the left-hand side of the line. So one other piece of information is that this first graph doesn't include the point 2. So what I'll need to do is at x is equal to 2, put in an open circle, to show that it's not inclusive of that point. Now, the other graph, this graph sits on the right-hand side of our boundary, and it's a line y is equal to x minus 3. So if you were to draw this line, normally, we would have the x intercept of 3. Let's say it's like roughly here, 3. Okay, our line would look something like this, normally. But the thing is, we only want to take the part of the line that's on the right-hand side of our boundary. So we'll only take this part of our line, okay? So in order to get that part of the line, we need to work out where this point, or where the line will start. So we know it's at 2, but the y value we need to figure out. We can do that by plugging in 2 into this function here. It will give us -1. So at -1, oh, sorry, I rubbed that out, but that's okay. At -1, that's where my line will start. And I know my line looks something like this. So I'll just take the part of the line that's after that point, okay? And let me get rid of this boundary. I've also put a closed circle here because this line includes the point 2. And this is what my piecewise function will look like. One last thing that I'll do is I'll just put in the intercepts for the circle, and this is the final graph. Now we need to work out its domain and range. So for the domain, so this graph actually stops at -2, okay, and exists only on the right-hand side of -2. So the domain will actually be x is greater than or equal to -2, okay? So you can see that there's nothing exists on this graph past on the left of -2. The range, if you have a look, all right, so this part of the graph, there's nothing that's below y is equal to 1. So we know for sure -1. We know for sure that it will be y is greater than or equal to -1. But let's see if it has any upper limits. This circle does stop at 2, this semicircle. But the thing is, this line will continue on forever. So we won't be able to put a lid on this graph because the line continues on forever. So it's just going to be y is greater than or equal to -1. Okay. Let me pause here for a second. If you do have any questions, just note them down. So that way, when we get to the mid-session break, you can ask them then. All right, we're doing pretty well for time. All right, let's have a look at this one as well. I'll give you guys just 30 seconds to think about this one, what the domain and range should be. Okay, so for this, the domain will actually be all real values, yeah? Because this graph, even though it doesn't have arrows on it, I mean, you can assume that there are, it extends forever left and right, and at this discontinuity, it's still including the point x is equal to -2 on the top branch. For the range, the graph only exists at y is equal to 1 or y is equal to -1. Okay, so it exists only in 2 places. All right. Now, this question we'll be skipping, but it will appear in the annotated slides. And let's move on to the next section now, the discriminant. Okay, so for the discriminant, if you have, first of all, the discriminant is given by this formula, and if you're not really sure where this comes from, it comes from the quadratic equation. So the discriminant is specifically the parts inside of the square root. Okay, and if you think back to when you were solving quadratic equations, the nature of what's inside the square root will tell you about the answers to a quadratic equation. So if you had this discriminant or the part inside the square root to be less than 0, you would have no solutions, or in other words, no real roots. We say real roots because there are what we call imaginary roots, which is something that if you do extension 2, you'll look more closely at. If we have our discriminant to be greater than or equal to 0, we have roots. Yeah, we have real roots. So you could have your discriminant being equal to 0, in which case you would have 1 root, or you could have your discriminant being greater than 0, in which case you'll have 2 distinct roots. Now, this one does come up quite a bit in the format of something being a tangent. So if something is a tangent or touches another graph, which is some of the questions we'll look at today, then we'll be looking at cases where the discriminant is equal to 0. Okay. One other thing that I wanted to mention, actually just a few more things, is that if your discriminant is a whole squared number, then your roots will be rational. Yeah, so for example, if your discriminant is 4 or 16 or 64, then your roots will be rational. Okay. One other thing that I wanted to mention is that if your discriminant is less than 0, yeah, so we have no real roots, and your coefficient in your quadratic, so think back to how the quadratic is structured, it's in the format of ax squared plus bx plus c is equal to 0. If your a value or the coefficient of x squared is greater than 0 and your discriminant is less than 0, then we have what we call a positive definite. Okay, so in this scenario, we have what we call a positive definite. It means your parabola is always has positive y values. If you have the discriminant to be less than 0 and your a value is less than 0, so something negative, the coefficient of x squared. Then you have a parabola that's always concave down, and what we would say to be a negative definite. Okay, so that's pretty much all the theory for discriminants and a little bit beyond with the positive and negative definites. But this theory should help us to answer the questions. Okay, let's have a look at the types of exam questions that will appear in your prelim. So the easy style questions will just ask you to calculate the discriminant straight off the bat. Yeah, you'll just ask you to calculate, what is a discriminant, or they'll ask you to show how many roots a quadratic has. Now, for a more difficult style question, they'll ask you to find a particular missing pronumeral. They'll give you a quadratic, and there'll be a missing pronumeral, and they'll ask you to find it given that there are 0, 1, or 2 root roots. Or you'll be asked to prove that something is a positive or negative definite, like the question, or like the theory that we just looked at. The last or the most difficult style of questions that will come up are tangent-related questions. They'll ask you, okay, what values of m or what values of k in this line or this equation will make this equation a tangent to another equation. So we'll look more closely at these styles of questions today. Okay, so let's start off with this one. I want you just to think about this. You can just quickly scribble down an answer. I'll give you guys 30 seconds to think about this as well, and then we'll quickly run through this. Okay, how's the quality now? Is it still holding up? We've got pretty much 40 seconds left, 40 minutes left in my part of the session. Okay, let's have a look at part A. So we need to find the discriminant. So discriminant is given by b squared, so 3 squared minus 4ac. And if we plug this into the calculator, it should come out as negative 23. Okay, part B asks us to state how many zeros there are. So because the discriminant is less than 0, there are no real roots. Okay, and even if let's say this was positive, it wouldn't be something that would be rational. Yeah, so if this was positive 23, this is not a square number, so it wouldn't be rational. Okay, so that's that question there. All right, the next question we will be skipping, but if we do have some more time, we'll come back to this. This question comes from North Sydney Girls, 2005 paper. And this is what I meant by the medium style questions, where you have to find a missing pronumeral. The solutions for this will be in the annotated slides. The next question also is kind of in that same style, where you have to find a missing pronumeral. This time, given that it's a positive definite, like we discussed in the content section. This one will also be skipping during the session, but will be in the annotated slides. So that one came from Volko. This question, though, we will be doing together. So I want you guys to have a think about if you would know how to answer this question. So I'll give you guys again 30 seconds. Think about if you would know what steps to take in order to figure this question out. Okay, let's go through this together. So if you were to just solve this, yeah, let's say that you wanted to work out the points of intersection, you will need to solve these two things simultaneously. And what it means when it says that the line is a tangent to the circle, it means that there's only one point of intersection. Yeah, so we've solved it simultaneously, and we found that it has only one point of intersection. So what we'll need to do is pretty much follow those steps. We'll need to solve it simultaneously and figure out the value of k such that our solution would only have one value. Okay, let's start by solving it simultaneously. We'll use a substitution method. We'll plug this in for y. So we get x squared plus 2x plus k whole squared is equal to 25. If you expand this out, we get x squared plus 4x squared plus 4kx plus k squared is equal to 25. I'll tidy this up a little bit. So I'll have 5x squared plus 4kx plus k squared, and I'll pull the 25 to the left-hand side. So I get this equation here. All right, and what I want is for this equation to have only one solution. So what that means is that I need my discriminant value to be equal to 0. Yeah. So let's work out the discriminant. Now this, before I actually go ahead, this is my a value, this is my b value, and this is my c value. So you might be confused. Well, k isn't that a variable? Well, no, because here our variable is just x. Yeah. K is some constant that we don't know the value of, but it's still a constant. So this stuff here will still be a constant term. So our c term. So let's go ahead and use the discriminant formula. So we have b squared minus 4ac. Okay. And if I simplify this, this comes out as 16k squared minus 20k squared plus 500. Okay, and this will be equal to 0. From here, if we simplify this down a little bit, we have negative 4k squared is equal to negative 500. Okay, k squared will then equal to, actually, let me just jump straight to the value of k. The k value will just be plus minus square root 125. If I want to simplify this a little bit, it'll be plus minus 5 root 5. So that means the value of k, okay, for which this line will be a tangent or touch the point, touch the circle at one point, is when k is equal to either positive 5 root 5 or negative 5 root 5. And you can actually play with this in decimals. We don't have enough time to do that today, but this is a question that's very similar. So I didn't mention this, but Phoenix questions are very similar to ones we've had in previous exams. So this particular question, especially for the guys in my class, will come up in the final exam that we have. So make sure you know how to do so. So let me just check the chat. Okay, Sachin says it's unreadable. Can you guys read this? I don't know why we're having so many technical difficulties today. Is it unreadable for anyone else? Okay. All right, let me just pause here for a second so that maybe can buffer its way. Okay, Rafid still says on and off. Okay, let me pause here for a second. Hopefully you can just have a look at the working. Okay, blurry only sometimes, but gets clear after a bit. Okay, so hopefully when I pause, it can like render out on your end. All right, so have a read of this solution. If you do have any questions, make a note of it so that we can come back to this during the mid-session break if you do have any questions. Okay, let's move to the next part. So this is further trigonometry. And I think it's the last bit of content that I need to teach you guys. So if we can get through this fairly quickly, then we can have some more time for questions. All right, so in this particular section, the types of questions that will come is pretty vast. Okay, trig is like a pretty big topic in the year 11 course. So we've got trig equations. You can also be asked identities, trig equations with identities, although that's not as common at the unit level. You could have unorthodox domains, so rather than it being between 0 and 2 pi or 0 and 360, it could be between, say, negative 180 and positive 180. You can also be asked arc length and area of a sector and segment calculation questions. we'll be looking at a lot of these types of questions in today's session, because these are the ones that I feel like are kind of glossed over, but appear in harder styles of questions in your exams. And then finally, you've got sine or cosine rule, or you also have 3D trig, just regular right angle trig, although that might not be too common in your final exams, given that you're now like almost year 12 students, so they wouldn't be asking stuff that basic. So you've got sine or cosine rule in both 2 dimensions and 3-dimensional applications. You've got bearings, so very common questions, bearings. So if you are unfamiliar with bearings, you will need to do some practice. We haven't included anything from here because it does come from year 10 and year 9 content. So by now you should be pretty familiar with sine and cosine rule and bearings. If you want though, it's okay. We'll include questions of this style in the annotated slides that we'll send out to you guys. Okay, so here's the very first question. So this one's a Phoenix question as well. So have a think about this one. See if you know how you would approach this. Oh, so the domain for this should have been between 0 and 2 pi. So I'll give you guys just 20 more seconds to think about this. Okay, so this is a particularly hard question because there's a lot going on here with the 2 theta. So one thing is that when you do have 2 theta, when you go to find your initial solutions, because we will be dividing by 2, we can extend our domain to twice what we have. So we'll look at 0 to 4 pi, and that will be the initial domain that we'll look at before we divide by 2. So we know exactly which solutions to include. Okay, so what I'll do, I would write a little bit bigger as well, so in case it's blurry. You guys can maybe hopefully make it out if it's a little bit bigger. So I'll pull everything to the left-hand side, and then I'll factorize out sine 2 theta. So I get 2 sine theta, 2 theta minus 1 is equal to 0. From here, I have sine 2 theta equal to 0. And I also have sine 2 theta being equal to half. Okay, so I've got 2 branches that I need to solve. For this first one, let's focus on that first one first. Let me just put this off to the side for now. So in this case, the right-hand side is something positive. Okay, so sine is positive in the first and second quadrants. So that's where we'll, those are the 2 quadrants we'll look at. So sine is 0 when theta is 0. And this second quadrant has a formula pi minus theta. So the second solution that we'll pull out is pi, okay? But because our extended domain is now up to 4 pi, we can include a lot more solutions. So what I'll do is I'll add 2 pi to 0 to get the next solution in the cycle. And then I'll also add 2 pi to pi, which gives me 3 pi. That will give me the next solution for pi in the cycle. Okay, I can fit in one more solution. If I add 2 pi to 2 pi again, I end up getting 4 pi. So pretty much what I've done is I started off with these 2 solutions, and then I added 2 pi to 0, and then 2 pi again to get my full set of solutions in this domain. And then to pi, I've added 2 pi as well to get the next solution in the cycle. I could add 2 pi again, but I would end up with 5 pi, which is outside of the set of solutions that I need in my domain. What I'll do now is I'll divide everything by 2 to get my value for theta. Okay, so for my first set of solutions, these are the solutions that I have, yeah, for the first branch. Okay, now let's have a look at the second branch. So in this case, my right-hand side, my value is positive again. So I'll look at the first and I'll look at the second quadrants as well. So I have 2 theta is equal to now pi on 6 is a value for theta that makes, or like the base angle that makes sine equal to half. And in the second quadrant, the solution from the second quadrant will be pi minus pi on 6, so 5 pi on 6. Now, one thing that I'll mention is that notice how I'm putting all my solutions in terms of pi. Yeah, you might be tempted to move between degrees and radians. You shouldn't really do that. If your domain has been specified in radians, you should answer everything in radians. If it's in degrees, everything should be in degrees. Okay, so these are my 2 base solutions, but what I can do is add 2 pi, okay, 2 pi on 6, and that will give me 13 pi on 6. Okay, so this is the next solution in the cycle. And I'll also add 2 pi to 5 pi on 6. That'll give me 17 pi on 6. Now I could add 2 pi again, just to check, so I get 25 pi on 6, but this is more than 4 pi, yeah? So this is outside my extended domain, so I won't add 2 pi anymore. Now what I just have to do is I need to divide everything by 2. And this ends up being the full set of solutions for my second branch here, okay? So in total, this has 9 solutions. Okay, so what you should do in an exam is just write them all together if you have some extra time, but it's fine for it to be separated like this. Okay, I'll pause here for a second. Yeah, we've got just about 20 minutes left. So that should be enough time to go through everything that we have in the trig section. Okay, here's the next question. I want you guys to have a think about this one. See if you know how to answer this. I'll give you guys 30 seconds. See if you know how to answer this one. And notice that now we have an unorthodox domains between minus 180 and positive 180. Okay, let's have a look at this question. All right, so the first thing that I should do is convert the cot x into tan x. Okay, and then I'll multiply everything by tan x to get it all, to get rid of the fraction. And I end up with this, and then I'll pull everything to one side. Okay, and now what we have is a quadratic, okay? And I just need to factorize this. So if I do factorize this, I can split the middle term into this, okay? And then I'll factorize in pairs. And if I do, let me just skip straight to the factorized form. I end up with tan x minus 1 and tan x minus 2 is equal to 0. Okay, so again from here, I'll have 2 branches to solve. I have tan x is equal to 1, and I'll have tan x is equal to 2. Okay, so let me tackle this one first. Now, tan, in this case, is positive, so I'll be looking at the first and third quadrants. Now, the value of tan that makes it equal to 1 is 45 degrees. And in this quadrant, I have 180 plus 45, which is 225 degrees, okay? But you can see that this is already outside of my domain. Now, what I need to do is I need to look back at my negative solutions. In order to do that, I need to subtract 360 from each of these. So let me subtract 360 from 45, and let's see what the solution in the negative section is for that. If I subtract 360, I'll get negative 315, which is outside my domain, unfortunately. And what I'll do is I'll subtract 360 from this as well. See what the negative version of this solution is. That comes out as negative 135 degrees. So that is actually within my domain. So from here, I've pretty much acquired two solutions, 45 and negative 135. Okay. And notice this time I'm answering all in degrees because my domain was in degrees. Okay, so now what I'll do is I'll solve this second branch here. So what I'll need to do is figure out what value of tan gives me 2. And also this is positive, so I'll look at the first and third quadrant. If I do tan inverse of 2, I get 63 degrees and 26 minutes. Okay, so that's my angle in the first quadrant. The angle here would be just 180 plus that. So that would be 243 degrees and 26 minutes. Okay, so these are my two base solutions. And now what I need to do is I need to see what other solutions I can find in this domain here. This one obviously is outside the domain, but let's look back again and look at the negative versions of these solutions. I'll subtract 360 from the first solution. That will give me negative 296 degrees and 34 minutes if I plug that in. I'll then subtract 360 degrees from 243. So this will give me negative 116 degrees and 34 minutes, okay? So from here, these two solutions are outside my domain, but these two are within my domain. So in total, I have 4 solutions. I've got this one, I've got this one, and this one. So you should drive it all out. But since we're a little bit short on time now, we'll skip past that. Okay, I'll pause here for a second. Hopefully it will render out if it's still laggy on your end. All right, let's jump to this question now. So this is an identity question that you need to prove. A lot of these questions are from Phoenix papers. Have a think about this. I'll give you guys 30 seconds. See if you can figure out how you do this question. Okay, let's start with the left-hand side here. So what we'll do is we'll change the cosec and sec into its regular sine and cosine version. So I'll rewrite cosec as 1 on sine x. And I'll write sec x as 1 over cos x. Okay, and what I'll do now is I'll make this all into one fraction, the top. So 1 minus sine squared x divided by sine x divided by, now I'll divide the bottom, which is 1 minus cos squared x divided by cos x. Okay, and what I've done is I've just written them separately, so it's easier to manage. So this top stuff is here, divided by the stuff in the denominator, which is here. Okay, now this stuff, if we use the Pythagorean trig identity, will just be cos squared x divided by sine x times, now I'll flip this over, this will be cos x divided by, again, if I use the Pythagorean trig identity, this will be sine squared x. Okay, now the tops I can multiply. This will be cos cubed x divided by, I'll multiply the bottoms, which will be sine cubed x. Okay, I've got cos cubed x divided by sine cubed x. This is just going to be cot cubed x. Okay, and is equal to what I needed to prove on the right hand side. Okay, I'll pause here for a second. So again, if you do have any questions, just save them for when we get to the mid-session break, which is coming up in a second. Okay, let's now move to this question. So this is the second last question that I'm going to do today with me. So have a read of this question. See if you would know how to tackle this one. So this isn't that hard of a question, and we'll look at a harder arc length type question in the next slide. So just 20 more seconds to think about this one. Okay, so we're told that this is the arc length from a circle that has radius of 10. So pretty much this is the segment that we cut out of the circle. This part is 10. We're told that this is the midpoint, so each of these parts will be 5. The question asks us to figure out the perimeter of this shape here, okay? So we already know this length, but there's 2 that we need to work out. This length here, and we need to figure out what this length here is. Okay, so let's start by figuring out what TQ is. To figure out TQ, we need to use the cosine rule in this triangle here. So we have TQ squared is equal to 5 squared plus 10 squared minus 2 5 times 10, and then cos 2 pi on 3. Now, one thing is that this question asks us to provide the answer in the exact form. So you need to actually check to see if this will be anything that has an exact value. If you plug into the calculator, you'll see that it comes out as, I think, -½ or something. But if it was, for example, square root 3 on 2, you'll need to work this out on its own and then simplify everything down. But because it's a nice number, it's a rational number, what I can do is just plug this all into the calculator and I get 175. So that means TQ will equal to root 175, which is equal to 5 root 7, okay? All right, now that we've worked out TQ, we just need to work out what PQ is, okay? And this is just the arc of a full circle. So we need to work out this arc length here. To work out the arc length, we have a formula for that. It's arc length is equal to the radius times the angle, where the angle is in radians, okay? So PQ would just be equal to the radius of the circle that subtends that arc, which is of radius 10, like we're told, times theta, which is 2 pi on 3. This comes out as 20 pi on 3, okay? So that means the perimeter is just going to be the 5 that we had at first, plus this length here, which we worked out as 5 root 7, and this length here, which we just worked out as 20 pi on 3. So this will be 5 plus 5 root 7 plus 20 pi on 3, okay? And this is the answer to this question. I'll pause here for a second as well. Okay, let's move to the next question. So this is the last one for the first half of the session. So I'll give you guys just 30 seconds to think about this one as well. Think about if you would know how to do this question. This one's, I would say, a hard one to have in an exam. Okay, let's have a look at this question. So part A asks us through what angle will P rotate if the ball or the wheel rolls 1 meter. So what that means is that it's mapping out 1 meter of its circumference. Yeah. So when something rolls, it rolls along its circumference. So if it's to roll 1 meter, it would have rolled out 1 meter of its circumference. So that means we have an arc length because it probably won't be the full circumference, but even if it is, we can use the same formula, which is the arc length formula. We know that we're rolling out 1 meter's worth. The radius they told us is 40 centimeters. Okay, so we'll keep all the units in meters. So 0.4 times theta. So theta would actually come out as 2.5 meters. Okay, that's part A. Now part B, what would be the vertical height of P above the track at this stage? Okay, so pretty much after it's rolled out 1 meter, you have to think about how far the P, or like where P would be along the circle, which is what makes this question hard. Oh, sorry, it's not meter, sorry. This is just 2.5 radians. So if it's rolled out 2.5 radians, you have to think about where it will be on the circle. Now, if it had rolled out 480 degrees or pi radians, that would be 3.14, yeah, which would mean that it would roll all the way to this side here, okay? But if it's only 2.5 radians, then it needs to be somewhere around here. Yeah, this is about 2.5 radians if this is 3.14. Okay, so our P ends up here. We've got our origin there. Okay, and what we need to work out is pretty much this length here. Okay, let's say that the ground is here. Okay, and we just need to work out what this length here is. So we know that the radius is 0.4. So let's sort of put in strategically our radius there, and we can also form a right angle triangle. Yeah, but this length we don't know what that will be. That's not 0.4 because it doesn't go all the way to the circumference. We also know that this part here, which is the same as this length here, okay, is 0.4 because this is also a radius. So this length here is the same as that length there. So all we need to do is we need to just work out what this length here is, and then we can just add 0.4 to figure out what the total height of the point would be above the ground. Now, in order to work out this length here, we can just use right angle trigonometry, okay? So we've got this right angle triangle. This is 0.4. We want to figure out what x is. So we need to actually work out the angle here before we do that. Now we know that this whole angle here is 2.5, but this is a right angle here. So this angle inside the triangle will just be 2.5 minus pi on 2, or 90 degrees. And the thing is, we are keeping everything in radians, so we haven't converted this into degrees. So we need to subtract pi on 2. If you subtract 45, you'll mess up your question. Yeah, so keep all the units in radians. All right, so pretty much we just need to work out x. So, or we can call this a, like I have in the work solutions, so keep it consistent. So let's work out not x, but the length AP. So if we take the sine of the angle, which is 2.5 minus pi on 2, this will equal to AP, so opposite, divided by hypotenuse. Now, when you go to actually calculate this, you need to make sure that your calculator is in radians. So if you try to type this in your calculator when it's in degrees, you'll end up with the wrong answer. So make sure you convert your calculator into radians, punch this in, multiply by 0.4, and this will come out as 0.39587. Okay, so that's just this length here. And then remember, we need to add it to 0.4 to figure out what the distance is. So the distance above the ground will just be this figure here plus 0.4, okay? So this will be 0.7959 to round it off to 4 decimal places, okay? And that's that last question. Okay, so that actually is it for the first half. So then, oh my God, I have missed one whole section. That is not good at all. Okay, sorry guys. So let's quickly actually run through this. We've got enough time. I'm just gonna go on our break. So let's quickly talk through random variables. So what a random variable is essentially just a variable assigned to something that's random. So for what we already have, like we've already dealt with variables in the past, yeah? For example, when you have, you're working out the number of apples that you can buy for, say, $50 if each apple is, say, 80 cents, for example. You'll be able to set up an equation pretty easily where, let's say, A is the number of apples. In that case, A would be a variable, but it would be something that is known. It's a deterministic variable because the number of apples we get is something that we'll know for sure. A random variable we use for something where we don't know what the value will be. There's some randomness to it. So for example, if I say I'm marking an exam and let's say I assign the variable X to be the marks that a student will get. I don't know exactly the mark that a student will get. There's a bit of randomness in it. So X is usually described to, used to describe, say, like a probability or like the outcome of something from a random experiment. And that's why it's called a random variable. It's just a variable allocated to something that's random. So we've got two types of random variables. We have discrete random variables, which can take on specific outcome values. So for example, if you're rolling a die, the outcome can be 1, 2, or 3. It's whole numbers. And that's what a discrete random variable is. So discrete means that it only increases in certain increments. A continuous random variable is, for example, something that describes continuous data like height. And this isn't in the year 11 course, yeah? So this is in the year 12 course. This is in the year 11 course. Some schools haven't actually taught this. So if you haven't been taught this at school yet and it's not going to be assessed, don't worry too much about this. Okay, so we're going to be looking specifically at discrete probability distributions. Now, a distribution just pretty much describes how probability is dispersed over the possible outcomes. So not always will all the outcomes have equal probabilities. When you roll a die, for example, all the outcomes do have equal probabilities. But if you are talking about, say, marks in an exam, not everyone will score each of the marks equally. So for example, they might be more concentrated towards 50% rather than 100%. Yeah, so the chances of getting 50% are higher than getting 100%. So that's where the probability would be distributed unevenly. They will be concentrated towards the more common scores. Okay, so that's just what a distribution is. Now, for a probability, for something to be a probability distribution, the probabilities must add up to 1, and the probabilities must be positive. And we'll have a look to see how that works through an example. Okay, but let's have a look at some of the other formulas. So we've got expected value. This formula looks very complicated, and if you've seen it before, you might have been a little bit overwhelmed when you first wrote, but it's fairly easy. So all you have to do is multiply the outcomes with a probability of that outcome. Okay. Next, we have the variance formulas. So this tells you we're looking at the expected value of the outcome squared minus the expected value squared. So we'll actually be calculating something with this formula. Then we've also got the standard, standard deviation. To calculate the standard deviation, it's just the square root of the variance. So pretty straightforward as well. Okay. I'm just going to quickly go through this because I completely forgot this topic was in the slides. So I was just taking it a bit slow. But the question is asking us, and this is a very common question that you get asked in the exam. It's asking us to find the value of k if this is a probability distribution. if this is a probability distribution, all the probabilities should add to 1. Yeah, so I can set this equation up. This means that 4k is equal to 0.8 and k is equal to 0.2. Now, one check that you can do is that after you get your value, you should be able to check to see if all your probabilities for each outcome is positive. Yeah, if it is, then your probability distribution is correct. Okay, let's move to this question here. I'll give you guys a second to read this. So this question is also very similar to a question in the year 11 final exam and also the mock exam that will be emailed out to you guys. Okay, let's go through this. So pretty much we've got a coin. These are the outcomes of the coin, 1 or 2, yeah? And we're flipping it twice and we're adding together outcomes from the flip. And we've been asked in part A to come up with a probability distribution table that describes the possible outcomes. So what we'll do is we'll just create a pretty rough looking table. Now, if we're adding the values together here from the coin tosses, there's only certain values that you can have. Okay, so you can no longer have a value of 1, for example, because you need to toss at least a minimum of 1 and 1. So the lowest value that you can actually have is a 2, a 1 and a 1. You can also have a 3, so from a 2 and a 1, or a 1 and a 2. And you can also have a 4 from a 2 and a 2. So these are the possible outcomes. And what we need to do is we need to work out the probability of these outcomes. So let's have a look. If we want to work out the probability of 2, this comes from a 1 and a 1. Probability of getting a 1 and a 1 is 2 on 3 times 2 on 3, okay, which is 4 on 9. Probability of getting a 3. So this comes from getting a 2 and a 1 or a 1 and a 2, okay? So probability of getting a 2 is 1 on 3 and getting 1 is 2 on 3. Okay, so this comes at us 2 on 9 and 1 on 1 and then 2. So this is actually a different outcome. 2 and 1 is one outcome and 1 and 2 is another. The probability of this is 2 on 3 times 1 on 3, which is the same as the first scenario that we looked at. Okay, and finally, for a 4, you need a 2 and a 2. Okay, so this would just 1 on 3 times 1 on 3, which is equal to 1 on 9. So to get a 3, there's actually a probability of 4 on 9, and a 2 is 4 on 9 as well. So let's just write those probabilities in. For a 2, it's 4 on 9. For a 3, it's 4 on 9 as well. And for a 4, it's 1 on 9. And you can double check to see if you've done this right by adding these together. You can see that it is adding up to 1, so it's a probability distribution. Okay, now part B asks us to calculate the variance of this new variable. So we'll look at the formula. The variance is given by expected value of the outcome squared minus the expected value of y whole squared, okay? So let's quickly calculate the expected value of y. So to do this, we just multiply the outcomes with their probabilities and add them together. So 2 times 1 on 9 plus 3 times 4 on 9 plus 4 times 1 on 9, okay? And this comes out, if I plug it into my calculator, as 8 on 3. Next, I'll calculate the expected value of my random variable squared. So to do this, I need to basically do the same thing as my expected value, but instead I square my outcome and then I multiply it with the probability. So I have 2 squared, which is 4, times, sorry, this should have been 4 on 9, times 4 on 9, times 3 squared, which is 9, times 4 on 9, sorry, this plus, and finally 4 squared, which is 16, times its probability 1 on 9. So what I've done is pretty much the same thing, but I've done my outcomes squared with the probabilities. If I add all of these together, this comes out as 68 on 9. Now let's bring this back to my formula. I have the expected value of y squared, which is 68 on 9, minus the expected value of y squared. So I have 8 on 3 squared. This is 68. This is 68 on 9 minus 64 on 9, and this should come out as 4 on 9 as my variance. As a side note, they didn't ask for the standard deviation, but if they did, we would just take the square root, which would be 2 on 3. Okay, and that is it for discrete distribution. So pretty much these two examples covered everything that you'd be asked in discrete probability. Okay, now we have, well, we're meant to have a 10-minute break, but since we're running a bit behind schedule, we'll just have 5 minutes. So take this time just to relax, have the stretch, maybe grab a snack. But if you do have questions, now's the time to ask. So I'll just stay on here for a few more moments. And I'll pass this over to Swadhin. So if you do have any questions, ask away. Okay, it looks like Swadhin, who's meant to be taking you guys for the second half, is also experiencing some technical difficulties. So just give us a second while we sort this out. I'm not sure what it is. Everyone seems to be having internet problems today. We'll be back in action in just a bit. Okay, guys, we're still experiencing some issues. We haven't been able to get swabbed in on. Just give us a few more moments. Okay, I'm just switching over to Swadin now, so hopefully you'll be able to take it away from here. All right, Swadin, can you hear me? And can you see if you can share your screen? We'll try to work this out before I leave the meeting. Could you guys hear Swadin saying anything? Damn, this was not an issue yesterday. Okay.
Can you hear me now?
Yeah, we can hear you, Swadin.
Yeah.
Okay, can you try turning on your video? And we'll see if all that's
On the video?
Yeah, and connecting.
Okay, yep.
We can't see a video on the screen right now.
Wi-Fi connecting my Wi-Fi. Oh, yeah. All right, let me try.
Okay, we can see a video now.
Yep. I'll share content because I don't think I can do video and share content at the same time.
Okay. As long as we can see the content.
Yeah.
I wonder what's wrong today.
Same thing happening to you?
Yeah, we were just having some issues with lag today.
Oh.
Yeah. We can't see the screen right now. Sharing.
Oh, I'm gonna share content now.
Okay. Can you just share and then that way I can pass everything over to you.
Can you see it now?
Yeah, perfect. Okay, I'll leave you to it then, something.
Thank you. All right, so for the second part of the crash course, we're going to go through differentiation and probability and also other stuff as well. So, nope, we skipped through probability. No, we didn't. All right, so can you guys still hear me? All right. So with differentiation, there's a few rules that you have to remember in preparation for your prelims. So first principle, that's the limit rule. So something along the lines of the derivative of fx is equal to limit as h tends to 0, fx plus h minus fx on h. The chain rule, obviously when you're differentiating inside a bracket. The product rule, when two variables that you need to differentiate are multiplied together. Quotient rule, similar to the previous one, but divided. Continuity, this is where you use limits and differentiability to determine if a graph is continuous at a certain point. And differentiability. Here you use continuity, and if the graph is steadily increasing or steadily decreasing to determine if the graph is differentiable at that point. Okay. Anyways, we'll continue on. So first question, we want to differentiate square root of x using first principle. So first principle, remember it concerns the limit. So limit as h tends to 0, sorry, that was my bad, not meant to be an x there. Limit as h tends to 0 of fx plus h minus fx on h. Yeah, don't make this mistake, guys. So as h tends to 0, we first write fx plus h as root x plus h minus fx, which is root x, all on h. Now, we can't sub in h as 0 straight away because we still have h on the denominator. So what we'll do is we actually multiply both the numerator and the denominator by the conjugate of the numerator. That is the same expression of the numerator, except that the minus sign is replaced by a plus sign. This way, when you're multiplying this entity and this entity, it'll form something called the difference of two squares, which is root x plus, which is basically, let me just write it here, square root of x plus h whole squared minus square root of x whole squared, which is x plus h minus x, which then just simplifies to h. That's what we want to do. So in seeing that happen, we have this expression. Now from here, we can cancel out the h's on the top and bottom because they're common factors where the bottom h is multiplied by a bracket. Now that leaves us with the limit as h tends to 0, 1 over root x plus h plus root x. Now we can sub in h as 0 because we don't have a problem here. If we sub in h as 0, the denominator, it's not guaranteed that the denominator will be 0. We just get rid of this h term, which is like the final step of our differentiating first principles. So now we can sub in h as 0, which obtains as 1 on square root of x plus square root of x, which is equal to 1 on 2 root x. And yeah, that's pretty much it. So it's a pretty easy 3 marks, these type of questions, especially when you have something simple like square root of h. All right, now question 2. To differentiate these two, we have to use something called the chain rule. And it's because these entities are inside a bracket. So that's going to be differentiating a, we move the 2 down, the 2 comes down, and the power of 2 gets minus 1. So 2 times 2x plus 3, 2 minus 1. Now you have to multiply this by the derivative of whatever's inside the bracket, which is 2. So that leaves us with 4 times 2x plus 3. Part B, similar process, right? The 3 comes down, bracket stays the same. The power of 3 is deducted by 1, which becomes the power of 2. Now you have to multiply by the derivative of the inside bracket. That's just going to be the derivative of e to the power of 2x plus 1, which is 2 times e to the power of 2x plus 1. That simplifies to 6e 2x plus 1, e to the power of 2x plus 1 to the power of 2. And remember, you can literally add the powers of these indices because they're the same common base, e to the power of 2x plus 1. So it's going to be 6e to the power of 2x plus 1 to the power of 3. And if you want to further simplify that, 6e, just multiply this 3 by 2x plus 1, 6e, 6x plus 3. That'll be your final simplified answer. So yeah, another easy 2 and easy 3 marks here. Nothing too complex. Question 3, also pretty simple. I want to differentiate this expression. Just note that this time we have to use 2 rules. First, the product rule. Let's use that first. So let's label this as u and this as v. This as in this entire 2x plus 3 to the power of 2. So that leaves us with y dash is equal to u dash v plus uv dash, where the dash represents the derivative of u and v. So derivative of u, that's just going to be 1 times v as it is. It's going to be 1 times 2x plus 3 squared. U as it is, that's just going to be x minus 1. Then the derivative of v, now we have to apply the chain rule here. All right, so remember, using the chain rule, the 2 comes down, the bracket stays as it is, the power minus is 1. Okay, never mind. The power minus is 1, and then you multiply by the derivative of the inside bracket, which is just 2. That leaves us with 4. That leaves us with v dash is equal to 4 times 2x plus 3. Now we simplify that. That's just going to give us 2x plus 3 squared plus 4x minus 1, 2x plus 3. All right. All right, now question 3, which is basically the same as question 4. Whatever. All right, question 3. I want to differentiate this one. Now, because we need to differentiate in terms of x, and there's x on the numerator and x on the denominator, we actually have to use something called the quotient rule. And to remind you of what that is basically the derivative is equal to u dash the derivative of the numerator multiplied by the denominator as it is, minus the numerator as it is, multiplied by the derivative of the denominator over the denominator squared. So applying that, u dash is going to be 3, v as it is, root x plus 4, x squared plus 4, minus u as it is, 3x plus 1. Now v dash, what we need to do first is we need to first write v in terms of indices form. This way, we can easily differentiate it by using the chain rule. So our second step is going to be to differentiate v with chain rule. It's going to be half times x squared plus 4, a half minus 1, that's going to be minus half, multiplied by the derivative of the inside, 2x. 2's and 2's cancel. That's going to give you x times x squared plus 4 to the power of minus a half. And if we simplify that, that's going to be x on square root of x squared plus 4. Yep. It's going to be x on square root of x squared plus 4 over x squared plus 4, because that's v squared. Can I fit this here? Yeah, probably not. So that's going to be, yeah, I'm not going to fit this here. Start a new line. There you go. Oh, crap. All right. So I'm starting a new line here. Let's simplify the top. So it's just adding fractions, right? Putting them in a common denominator. Square root of x squared plus 4. This times this gives you 3 times x squared plus 4. Multiplied by x times 3x plus 1 minus 1. That was my bad. Now that equals 2. And just using simple arithmetic here. And that's it. There's your y dash. So a bit of a complex question, this one. You had to use essentially 2 different types of rules. And obviously the equation rule is a bit tedious for those who are first starting on with it. But it's a 3-marker question. I reckon it will be on the medium side if it comes on your prelims. All right. I'll be back. Hold on. Something wrong with my Wi-Fi right now. It's not going to take that long. Let me see if this works now. Right. And that works now. Yeah. So for this question, it asks us to find the equation of the normal to the curve specified by this parabola, where the tangent is perpendicular to that one. So right, so first what we need to do is we need to write this equation, into the form y is equal to mx plus b. This is because we can then easily find the gradient of this, m, and it asks us the normal to the curve where the tangent is perpendicular to this line. We can then find the equation of the tangent, and then obviously proceed with the question. But doing that first, drop all this up for now. Isolate the 4y. So 4y is equal to minus 2x plus 5. Then just divide both sides by 4. And that's going to give you minus a half x plus 5 and 4. We find that the m here is equal to minus a half. What are we interested in? We're interested in the equation of the normal to the curve where the tangent is perpendicular to this line. All right, that's not bad then. So it's perpendicular to that line. The tangent of this curve, which is perpendicular to this line, is equal to the negative reciprocal of this, which is just 2. Here we want to use the point gradient form. Yeah, y minus y1 is equal to mx minus x1. But what's our y1 and x? What's our x1, y1? Well, we can actually find x1 by applying derivatives. And here's how. Remember, your derivative equation, what does it give? It gives the equation of the gradient of tangent at any point x or any point y on that curve. What do we want? We want the gradient of the tangent to be 2. We already have a y equation here, so let's differentiate y. That's going to give us minus 6x. And what do we want? We want an x value such that the gradient, the y dash value, would equal to 2. So x is equal to minus 2 on 6, which is minus a third. And we can just simplify the y value by subbing in x is equal to minus a third into this equation here. It's going to be 3 minus a third squared plus 5, which with the help of a calculator will give you 14 on 3. Okay, continuing on. So our x1, y1 is now minus a third, 14 on 3. And our tangent is going to be, the gradient of the tangent is going to be 2. But again, what do we want? We want to find the equation of the normal to this curve, where this tangent is perpendicular to this line. So the normal to this tangent, we keep the point because that is a point where this tangent is perpendicular to this line. However, we have to change the gradient value into the normal gradient, which is now going to be minus a half again. So keeping these points, guys, it's really important to keep these points. Do this one first. Do the process where you find the point x1, y1 first, because that is a point where your tangent is going to be perpendicular to this line. Yeah, where it's going to be perpendicular to this line. And then find the normal to that line. So that's going to be the m normal. So proceed with finding the equation. Y minus y1 is equal to m normal, x minus x1. Y minus 14 on 3 is equal to minus a half, x plus 1 on 3. So that's going to give us half x minus the 6 plus 14 on 3, or the 6 here. Which gives us a nice equation of half x plus 9 on 2. Final equation. So a slightly tricky question. That's why it's a 3 marker, essentially. It will come on your prelims, I reckon, but it'll be on, it might be like one of those hard questions that they put right in between the tests. So always be prepared for it. Don't assume it will not come. Right. So this is a question of continuity, and it's from a Phoenix paper. So let's consider this function. We want to show first that the function is continuous at x is equal to 0. How do we do that? Remember the continuity formula. Limit as x tends to the right-hand side of 0, of fx is equal to the limit of x tends to the left-hand side of 0 of fx, which is equal to f0. Okay, let's look at this piecewise function first. As x approaches 0 from the right-hand side, so using this equation here, what does fx approach? All right, it approaches the value of fx as x is equal to 0 using this equation. We're not evaluating fx at 0 explicitly here. We're simply determining which value fx approaches as x is just a little bit greater than 0. That's what it says, as x approaches 0 from the right-hand side. So when x is just a little bit greater than 0. So that value is, we put this arrow here, it's not equals to, that value is 1. Now what's this value? This is when x is just a little bit less than 0. Oh crap, okay, I got that mixed up. For this equation, for this one, I was meant to use this one, right? So that was my bad, because it's when x is a little bit greater than 0. So minus 0 plus 1 is 1. Now for this one, I use the first equation. So when x is just a little bit less than 0, it's going to be minus 0 squared plus 1, which is just 1. Now what's f of 0? Can that be evaluated? Well, yes, it can, because we're given an equation here for when x is greater than or equal to 0. This equal to sign means that we can sub in f as 0 onto this equation of the piecewise function. And that's equal to minus 0 plus 1, which is equal to 1. This is equal to this is equal to this, therefore continuous. So therefore fx is continuous at x is equal to 0. Yeah, that's what we need to do. Now we need to show that the function is not differentiable at x is equal to 0. Most of you guys will just draw it out and show that there's a vertical cusp, but there's a more professional way to do it. Let's consider the derivative, right? So minus 2x, derivative of this is minus 1. This is for x is less than 0, and this is for x is greater than or equal to 0. Okay. So what's f of 0? F dash 0 is going to be minus 1, this constant function here. What's the limit as x tends to 0 plus of f dash x? That's equal to minus 1, because that's what it approaches as it just goes to minus 1. What's the limit as x tends to 0 minus f dash x? That's going to be whatever this approaches. So 2 times 0, which is 0. Now, this is not equal to this and this, which is what breaks the change of the equality to hold the differential condition to be true. In other words, limit as x tends to 0 minus f dash x is not equal to limit as x tends to 0 plus f dash x, which that is equal to f dash 0. So because this chain is broken, therefore not differentiable at x is equal to 0. That's pretty much it for differentiation. Now we move on to logarithms and exponentials. All right, so this topic is essentially carried over from year 10, just the logarithms part mainly. Exponentials, you learn it in year 11 as well. So just a heads up with that one. So first question we're given is a 1 marker from Sydney Girls High School 2019. And it's a very chemistry-based question. If you guys do chemistry right now, you know that the pH is a logarithmic scale. All right. So shampoo A has a pH of 9.2 and shampoo B has a pH of 10.1. The pH scale is base 10 logarithmic. How much more alkaline is shampoo B than shampoo A? And it notes here that the alkaline, if the solution is alkaline, if pH is greater than 7. So in my opinion, this question literally only benefits those who do chemistry, but those who do not, we'll go through it right now. Okay, so what's the difference in pH? The difference in pH is 10.1 minus 9.2, which is 0.9. And remember, this is base 10 logarithmic. Log base 10 of something of x is equal to 0.9. And this x value is 10 to the power of 0.9, which is 7.94, whatever. So it is 7.94 units more alkaline. I don't think they'll give you this question anymore because it's not fair to people who don't do chemistry. It's not even the right chemistry anyways. But if you do get a question, just remember to extract what you know from the question. What you know is it's base 10 logarithmic, the pH scale, and you find x in such a way. All right. Question 2, solve this equation. Simple algebra here. So ln x plus 1, we want to group the x plus 1s together. Remember, ln is equal to log base e. Now, using our log laws, ln x plus 1 plus ln x plus 3, that amounts to ln x plus 1 times x plus 3, which is equal to ln 15. Now, because both have the same base, which is base e, taking the power of e to both sides would yield this. Or we can just equate whatever's in the bracket if it's on the same base of logarithms. X squared plus 4x plus 3 minus 15 is equal to 0. X squared plus 4x minus 12 is equal to 0. X, can you factorize this out? Yes, you can. X plus 6, x minus 2, greater than or equal to 0. And we can solve this by drawing a simple parabola, which represents this equation here. So intercepts are minus 3 and 2. Y-intercept that, you don't really need to know that. He just needs to know where the parabola is greater than or equal to 0. So this is that x is less than or equal to minus 6, or x is greater, should say, and x is greater than or equal to 2. You can say and or, doesn't matter. But yeah. Basically where the parabola is greater than or equal to 0. Same question here, not needed. All right. This question is from Sydney Grammar 2019, and it's a graphing question. You want to graph this exponential function and this one on separate number planes. So this is exponential, this is logarithmic. Two different graphs here. So remember, with an exponential function, the general function looks like this, right? A general function a to the power of x has a y-intercept of 1, increases this way, decreases this way, and has an asymptote at y is equal to 0. That's the general function of a to the power of x. What we have now here is 2 to the power of x minus 4. So to sketch that, we know that such a graph would need to be translated 4 units down. So let's draw a skeleton sketch first. A skeleton sketch is what I like to draw first, right? The asymptote is, this is the sketch of y is equal to 2x, skeleton sketch, before we apply any translations. So asymptote is at y is equal to 0. But it's 2 to the power of x minus 4. So if we translate it 4 units down, the new asymptote should be at minus 4. And the new intercept should be at minus 3. Do we need to show x-intercepts? Yes, it says show all intercepts. Now to find x-intercept, we just simply equate this to 0. X is equal to 2. It's not too bad, right? So that's y is equal to 2x minus 4. Asymptote at minus 4, y-intercept at minus 3, x-intercept at x is equal to 2. So 2 marks for showing all that. Part B, a logarithmic graph. This time. Sketch is not so bad, I'm sorry. All right. Now with logarithms, right? The general logarithmic graph looks like this, all right? So the skeleton graph, this one, has an x-intercept at x is equal to 1 and an asymptote at x is equal to 0. So vertical asymptote. And with log base 3x, it doesn't really change much. Our x-intercept is still 1 and our asymptote is still y is equal to 0. So you can just keep this graph as it is. Just if you want to be fancy, note that log base 3, 9 is equal to 2. So at 9, you can just say that the graph points at 2. But I don't think you really get marked on that. Actually, maybe, because it says, and other important features. You want to distinguish this graph as different from other logarithmic graphs because it's log base 3x. And that's it, this one. Yep. All right, this is a long worded problem. Just open something else. All right. So let's break this down. In January 2018, a farmer accidentally spread a dangerous chemical on cattle. This concentration of the chemical in the soil, the concentration was found to be 3.2 kilograms. It's decreased from 7 to 3.9. Okay, now it's known that the concentration C of the chemical is given by this formula. C is equal to C0 exponential e to the power of kt minus kt. And this formula, if you guys know, is known as natural decay. It's when chemicals like disintegrate. Right? Part I asks, find the values of C0 and K, giving answers in exact form. For this one, we need to look for initial conditions, right? So rewrite this equation. C is equal to C0 multiplied by exponential minus KT. Now, initially, it's measured to be 7 kilograms per hectare. So 7 is equal to C0 times e to the power of 0, which is just 1. So 7 is E0. So C is equal to 7e minus KT. What else do we know? 1 year later, concentration was found to be 3.2 kilograms per hectare. So at t is equal to 1, C is equal to 3.2. So 3.2 is equal to 7e to the power of minus k, because minus k times 1 is just minus k. E to the power of minus k is equal to 3.2 on 7, which is 16 on 35. So k is equal to minus logarithmic e, 16 on 35. Yeah, that's k. And two marks, 1 mark for finding and the other mark finding. Oh crap. I just got back in and I'm not the host anymore. I'm gonna try share screen and it's not letting me as host. All right, Cheyenne, can you hear me? All right, yeah, Cheyenne, you're the host somehow. Are you able to transfer the host ownership to me? Try do it on settings. Okay, wait. Let me just show you. So try go on meeting settings. Oh, you done it? All right, thanks, bro. Cheers. Okay, sorry about that one. That was just a lag. Okay. Can you guys see my screen now? Can you guys see my screen now, guys? All right, thank you. Yeah, sorry about that, Misha. So when is it safe? Okay, so is it safe to use so it says it's safe to use a paddock when the concentration falls below 0.2 kilograms per hectare. During which year will it become safe for the farmer to use a paddock again? So let's calculate this. We have C is equal to C0, which is 7, exponential, minus log E, 16 on 35 T, which is 7 exponential log E, 16 on 35 T. Now, it's safe when C is below 0.2, all right? So let's find the time of the year for this one. So isolate E. I'm just going to write ln instead of log basically, guys, because it's a lot easier. So ln 16 on 35 T is equal to ln 0.2 on 7. Now T would be equal to ln 0.2 on 7 over ln 16 on 35, which is equal to 4.542 something years. So that's up to like 4.5 years. So after 2022, which is 2023. Yeah. And that's it. It says because it asked during which year, we have our answer as 4.4542, but because it has to fall below 0.2, we can't say it's after 4 years because after 4 years it's still above 0.2. So 4.5, let's round that up to 5 because we know that it's decreasing as the years increase. So that's going to be approximately 5 years later. 5 years later, it's going to be 2023 from 2018. All right. And that's pretty much it from calculus. We now move on to probability, most notably conditional probability. This is the one where it really gets you in exams. And I reckon from year 11, this was one of the more difficult topics. mainly because you need to know how to manipulate the formulas very well, which then themselves are really hard to remember. But once you do a lot of practice questions, you guys will be very familiar with it. All right, so an example of conditional probability that I'm going to go through right now, just to recap your minds a bit. So let's consider a sample of 100 people that I tested for a heart disease. We know that 20 out of 100 are known to have diabetes. So this many people out of this whole amount of people have diabetes. And after we find our investigation, 6 out of 20 people with diabetes also had heart disease. And 8 out of the 80 people without diabetes had heart disease. Now it asks us, what is the probability that someone has diabetes given they have a heart disease? Well, that's basically diabetes given, this vertical line in probability means given heart disease, which is equal to the number of heart disease with diabetes. That's how much we need to find. And our new sample space is the given condition. Our given condition is given that they have heart disease, which is equal, and that's divided by the sample space, which is number of people with heart disease. No heart. Whoever wrote that. So using this one, it's going to be 6 over 6 plus 8, which is 3 on 7. Okay, and this simplifies to this. The probability of event D given event H. And that's equal to the probability of event H given event D multiplied by the probability of event D over the probability of event H. That's the general arithmetic formula in conditional probability. All right. Now, conditional probability, this is the general formula. Probability of D given H is equal to the probability of H given D multiplied by the probability of D over the probability of event H. And this is basically describes the likelihood of an outcome occurring based on a previous outcome occurring. So here's question 1, all right? This is a Sydney Grammar 2019 paper. And it asks us, on any given day in Sydney, the probability that it is raining is 1 on 3. And the probability that there is heavy traffic is 7 on 12. So we have 2 different events that are given to us. Let's keep that in mind and keep note of this. And the probability of heavy traffic or it is raining, this or means these events joined together is 2 on 3. Part I asks us, what is the probability that it is raining and there is heavy traffic? Most people might as well just use this formula and try to approach with this way, but it's going to be very hard to find this quantity because you basically don't know. It doesn't give any probability case. So our best approach for part I is actually to draw a Venn diagram. So R is raining and H is heavy traffic, right? The probability that it is raining is a third. And the probability that there is heavy traffic is 7 on 12. And the probability that is heavy traffic or raining is 2 on 3. So this plus this is 2 on 3. So this plus this. Find the probability that is raining and heavy traffic. If we draw a Venn diagram and simplify the outcomes here, raining and heavy traffic is whatever that's in between. So 1 on 4. That's going to be 1 on 3 plus 7 on 12. Because remember, this 7 on 12 counts for whatever is inside as well. Minus 2 on 3. The probability that is raining or heavy traffic. That's going to be 1 on 4. Now part 2. Find the probability that there is heavy traffic given that it is raining. Now this is a traditional conditional probability question. So let's write our formula down. Probability of heavy traffic given it is raining is equal to probability of heavy traffic and raining over probability of raining. Now, pH and raining is the same as P raining and H, right? They're interchangeable because of this and symbol. So that's just going to be the same answer as the previous one, 1 on 4, over the probability of the rain, which is 1 on 3. Now that's going to give you 3 on 4. Let me just check the chat if there was any questions. All right, no questions. All right, this is question 2, and this is a traditional from like one of the traditional Phoenix exams. All right, since we have a bit of time left, I'm going to give you guys a minute or two to think about how you would do this given our conditional probability formula. All right, let's get through this. The meteorology report states that the following about any given day in Melbourne. The chance of the weather will be cloudy, giving you that rain is 40%. Chance it will rain on a cloudy day, 60%. And the chance that a day will not be cloudy is 75%. And it asks us, what is the probability on any given day that it will rain? Let's break this down now. We have quite a few events we need to deal with. So this is our formula. Event D given event H is equal to probability of H given event D multiplied by probability of D over probability of event H. So probability of rain, we have these two outcomes, right? So let R is equal to rain, C is equal to cloudy, yeah, that's pretty much it. So the probability, the weather will be cloudy given it at rain. So probability of C given R is 0.4. Let's convert it to decimals first because it'll be easier. Probability of raining on a cloudy day, so raining given it's cloudy is going to be 0.6. Now, chance that a day will not be cloudy is 0.5. So P not cloudy is 0.75. Now, using our probability formula, the probability of it being cloudy is going to be 1 minus 0.75, which is 0.25. So what do we have? We have probability of cloudy, we have probability of rain given cloudy, and we have probability of cloudy given rain. Now let's try apply to our formula to find the probability of rain. Start a blank page here. We know that. Let's deal with this one first. Probability of C given R is going to be equal to probability of R given C multiplied by the probability of C over the probability of R. Right? What's R given C? R given C is 0.6. 0.4 is equal to 0.6. What's PC? That's 0.25. Yep, and PR. PR is a probability that it will rain. So now let's find PR. We can easily find it because all we're left with is just numbers on the numerator and a number on the on the left-hand side, sorry. So P of rain is going to be equal to 0.6 times 0.25 on 0.4. That's going to be 0.375, and that's the probability that it will rain, which is 37.5%. Exactly. So yeah, this is a pretty tricky question. I reckon this will be around 3 marks. 1 mark for figuring this out, another mark for combining it together, and the final mark for the correct answer. All right. So that pretty much brings us to the end of the crash course. What I want you guys to do now is to scan this barcode so you can receive the resources of this crash course through the email. And so while you guys are doing that, since we still have quite a few time left and we have nothing really to do, do you guys have any questions for me? Like, do you guys want me to go through anything again or explain anything again? I'm more than happy to, until 7:30. I need to go back to it because I'm using my iPad right now. I can't use my laptop. So I need to go back here to check the chat. If you guys have questions, just feel free to ask. If you're confident through whatever we went through today's crash course, you guys are free to go. But make sure you scan this email first to submit, so I can submit the resources to you guys. No worries. Yeah, those who have a question, just feel free to like ask on the chat or speak up. Otherwise, you guys are free to go. No worries. Yep, you too. Yep, no worries. Then